Alrighty, it's 7 o'clock. My name is Mr. Metter, subbing for Mr. Castro tonight. He and I worked together a couple years ago and taught at the same school, so I'm glad to be helping him out. We're going to start with a little bit of review. So I'm looking at your homework. I believe it's 4.3. And we're going to start with question 15. I don't have my computer set up all nice, so I'm just going to be using a whiteboard and some markers tonight. I hope that works. If you can't see something, you could turn on and tell me you can't see it or send a message so that I can get that. But I'm going to try to keep it as visible as possible. So first, I'm looking at question 15, which was a over 4 equals -2. This is going to help us set up for what we're going to get to today. I'm going to erase the problem number real quick. So all we have to do in this one to isolate the variable is multiply both sides by 4. And then these cancel out. And I'm going to write my next line, a equals, and then I'm just going to simplify this, -2 times 4, which is -8. All right, so when we have a number in the denominator, in order to get rid of that number, to cancel it out, we multiply it, but we have to multiply by it on both sides in order to keep our equation balanced. All right, let's look at another example from homework 3. This is question number 19. This is a multi-step problem where we're going to be solving for x. So we've got minus 5x plus 6 times -2x plus 4 equals -112. Right, so this is question 19 from your homework, which was homework number 3. Seems like there's a lot going on here, so we're just going to take it bit by bit, step by step. Following order of operations, I would look in the parentheses, but there are no like terms here. So I'm going to do multiplication. So I'm going to distribute this 6 to both of those terms. My minus 5x doesn't change. 6 times -2x minus 12x. 6 times 4 is 24. And my right side is unchanged. Now I have some like terms that I can deal with. I've got a -5x and a -12x. So I'm subtracting this from a negative, or you could think I'm adding two negative numbers together. So since they're headed the same direction, I'm going to add their values together, and they turn into a total of -17x. And I've still got plus 24 equals -112. Now, I've got to get rid of this 24. I'm adding 24 to my x terms. So in order to get rid of that 24, I'm going to subtract it. So I'm going to subtract 24 from both sides. So on this side, I've got positive 24 minus 24 will give me 0, leaving me with -17x. And then on the right side, I've got -112 minus 24. They're both negative, so they're going to add together and become an even larger negative number. So it's going to be -136. This is where the math takes a little bit of a step up. I have to isolate my variable, and now I've just got one step left. The last thing that's happening to x is that it's being multiplied by -17. So I'm going to divide both sides by -17. And this is where it gets a little tough. These -17s cancel out. So I'm got my eyes on the prize here. I've made it to x. Now I just have to figure out what -136 divided by -17 is. Well, two negatives make a positive, so I'm not worried about that. And then I've got a few different options for how I want to think about this, but it might be time to go to long division. Actually don't think that that would help us too much here. Hmm. I know that it's less than 10 times 17. So I'm gonna show you how I think about this. 10 times 17 would just be 170. And 136 is definitely less than 170. So what I can do is work my way down by subtracting 17 and see if I get to the answer. Got 9 times 17. Well, all I have to do to get that is just subtract 17 from 170. So I've got to borrow from here to make this a 10. So I've got 3, and then 6 minus 1 is 5, 153. Not there yet. Let's try one more. I'm going to do minus 17 again. So I've got 3 minus 7. I have to borrow. That's 13 minus 7 is 6. 4 minus 1 is 3. And 1 minus 0 is 1. So actually, I've made it to 136. So now I know that 8 times 17 is 136. That means that 136 divided by 17 is 8. So I can work it out that way and find that x equals 8. This multiplications of 17 is not something that we do all that often. So this is one of those numbers that you got to work at it to figure out how it's going to divide evenly to give you your answer. If you just came in, we just worked out number 19 from your homework. My name is Mr. Metter. I'm subbing for Mr. Castro tonight. Now we're going to look, I wanted to do one or two more problems like that, and then some percent problems, and then tonight's lesson. So let's look at number 21. This one has some negatives going on, and I think that's going to be important to make sure we review. So we've got negative 2 times negative 1 plus m plus 7 times negative m minus 7 equals negative 74. Now again, it looks like there's a lot going on here, but none of the individual parts are going to be too challenging, right? We're just going to take it piece by piece. First thing I'm going to do is take this negative 2 and distribute it by multiplying it by each of these terms inside the parentheses. So negative 2 times negative 1, two negatives make a positive. Negative 2 times m, negative 2m. Then I'm going to do the same thing over here. 7 times negative m, oh, almost missed that, is negative 7m. That's why we're reviewing this. Okay, make sure we keep track of negatives and positives. Then 7 times negative 7 is negative 49. And on the other side, we still have negative 74. So now I can combine like terms and see where I can go from there. I've got negative 2m minus 7m. It's the same. We got two negatives adding together are going to make an even larger negative. And 2 plus 7 is 9. So this is negative 9m. And then I have a positive 2 and a negative 49. So negative 49 plus 2. I've got negative 49, but then I add 2 more. The number gets smaller. So that's 49 minus 2. Negative 47. And then that is still equal to negative 74. Okay. Now I have to do some addition. I need to add 47 to both sides to get rid of it so I can keep isolating my variable. So that's going to give me 0. Got negative 9m on this side. And now I have to do negative 74 plus 47. Right? So that's the same as if I had 74 minus 47, but I know my answer is going to be negative because 74 is the larger number and it's negative. So I have to borrow 14 minus 7 is 7, and then 6 minus 4 is 2. That looks like it's turning out nicely. I'm going to rewrite it. Negative 9m equals negative 27. Almost to m, divide both sides by negative 9. So I'm going to have m equals, and this one is probably one that we're a bit more familiar with, that 27 is 3 times 9, and two negatives make it positive. So if you got m equals 3 on number 21, doing great, making progress on that one. All right, let's also review some of the problems from that same homework on percentages. All right, so the way you want to think about this, there's a couple different ways to set it up. We know that a percent is the part of a whole. Right, so if I had 1/2, that would be 1 out of 2. And I can always ask my calculator what that is, and it would tell me 0.5. Another way to think about this that makes problems particularly easy for this one is to read it and just turn it into an equation as you read it. So in number 23, we have what is 39% of 47? Well, what is x? X means what? We don't know what it is, so we're asking what. Is means equal, and then 39%, I'm going to use a dot for multiplication and an x for my variable, of 47. So this says x equals 39% of 47, which is the same as asking, what is 39% of 47? And I can't quite solve this as it is. I have to change 39% to a decimal. So I'm going to change that to 0.39. And then this is times 47. Right? And I am allowed to use my calculator to put that in. I'm not going to get that done in my head. And if I type it in right, and if I've done everything right up to this point, I get that x equals 18.3. I'll make that dot a little bigger so it's clear there. Right. So I have what is 39% of 47. I change percent to decimal, and then I just have to multiply these together to solve for the percent. Let's do question 25. I'm looking at the odds, that left column here, and I wanted to mostly look at those. I've got 4% of what is 43. Right? 4% of what is 43. Well, I can't use this number as it is. I need to convert it to a decimal, which is the same as dividing by 100. So I move my decimal point over 2 spots, and then I need a 0 placeholder. So this is 0.04 times x equals 43. Now, in order to isolate my variable x, all I have to do now is divide by 0.04 on both sides to make sure my equation stays balanced. These cancel out. I have x equals 43 divided by 0.04, and then I ask my calculator to do this work for me. But because this number is smaller than 1, this is a decimal, I'm expecting my answer to be bigger than 43. And actually, it's much bigger. It is 1075. So just ask your calculator how to do that. and you'll get 1075. So if you got that, then you're doing well on these percent problems. Let's do just two more of these, and then we'll move on to tonight's lesson. Number 27 says, what percent of 28 is 7? Right, so I've got some number here that's going to be a decimal, and that is going to be multiplied by 28. And normally, actually, we would rewrite it 28x instead of 8 or x times 28. And that equals 7. Now I have to divide both sides by 28. So I've got x equals 7 over 28. Now, when you're doing when you're doing percentages, you're allowed to use your calculator, but this might jump out to you as a multiplication because 28 is 7 times 4, which means this simplifies to 1 over 4, which is a quarter, right? And a quarter, 25 cents, 0.25 of a dollar. It's the same as that. So if you put 7 divided by 28 in your calculator, it'll tell you 0.25. If you put 1 divided by 4 in your calculator, it'll tell you 0.25. And now this is a decimal, but I want it to be a percent. So I have to multiply by 100%. And percent means 100. So what I'm actually multiplying by there is 100 per 100, which is 1. So I'm not actually changing it. Right? And this turns out to be 25%. Right? If you're thinking about it as part over whole and you start there, then we would start here with what fraction is, what percent of 28 is 7. 7 out of 28 is a fourth. I'm just finding it clearer to start just like this, read the sentence, turn it right into an equation, and then go from there. All right, we will do one more of these guys. Number 29. And again, I'm just reading straight through. 33 inches is what percent of 47? All right, so I'm just trying to make it as straightforward as possible when I'm getting to my equation. And I have 33 is what percent of 47? Well, to isolate my variable, I need to divide both sides by 47. And when I cancel these, I'm going to rewrite it. I'm going to flip it so that I have x on the left, just because that feels more right, feels more normal. Now you could, if you're thinking, oh wait, 33 is part of 47, and if I divide the part by the whole, I'll get the percent. These are the same two different ways to start. You could start here, or you could start here, whichever way you're most comfortable with, whichever way you think works better for you. I've got a fraction here, but I want it as a decimal. So I'm going to ask my calculator. I'm going to say, what is 33 divided by 47? I'm going to get 0.702. And to convert that, I multiply by 100, which is the same as moving my decimal place over 2. So the answer for number 29 is 70.2%. So hopefully these are making sense to you. That review helped. We're going to look at tonight's lesson. I want you to take notes. I'm going to give you examples that are increasing in complexity, but I think we'll be able to get there. So what we're doing tonight is solving proportions. We're going to start with a problem very similar to the first homework question that we did. All right, so let's say, just for an example, I had x over 3 equals 4. And I just want you to work these little examples along with me because they're going to build toward our new type of problem. Now to solve that, to isolate x should be pretty easy. I just have to multiply both sides by 3. These 3's cancel out. I have x equals 4 times 3, which is 12. Okay? But it's not always going to be just that easy. Sometimes we might have something like 3 over x equals, I'm going to use the same numbers for a minute here. 3 over x equals 4. Well, I've got x in the denominator, and I don't want it there because I can't really solve for it as long as it's in the denominator. So I'm going to do the same thing to it that I did to my denominators before when I needed to get rid of something. If I multiply both sides by x, these two cancel out over here, and now I have x in the numerator. There's no fraction over here right now, and I'd have something like 3 equals 4x. And to solve that, I just need to divide both sides by 4. So those cancel out, and I end up with x equals 3/4. Okay, so that's how we can get a variable out of the denominator. Let's do one more question similar to that, one more example. And I can pick any numbers here. I can have 7 over x equals 3. Right. See if you can work this out for a second. Try to stay just a step ahead of me here. Got that x in the denominator, and I don't want it there. I'm going to multiply both sides by x so that it's no longer in the denominator over here. Then I have 7 equals 3x. And then to isolate x, all I have to do at this point is divide both sides by 3. I have x equals 7/3, or if you wanted to write that as a mixed fraction, 2 1/3. We can have an improper fraction or a mixed fraction, but these are the same number. 7/3 and 2 1/3 are the same. Okay, so what if we take it one step further? We've had x in the numerator, we've had x in the denominator, but the other sides have always been one number, just the numerator. Now we're going to have a fraction equal to a fraction, and that's what proportions are. A proportion is a fraction equal to a fraction. So proportion looks like A over B equals C over D. Right? And what a proportion tells me is that these two fractions, though they might have different numbers, they're representing the same value and the same ratio of these numbers. So let's look at an example where we'll start with x in the numerator. I'm going to get rid of this little guy here so I have a bit more room. X over 3 equals 4 over 5. This is a proportion, and it should be pretty easy to solve because x is in the numerator. Things are harder when x is in the denominator. But x is being divided by 3, and all I have to do to cancel that out is multiply both sides by 3. So these 3's cancel out, and I have 4 times 3 in the numerator, which is 12, over 5. So that's one type of proportion that we might need to solve. But this one is just x divided by a number. The real fun is when we have a number divided by x. So that's 6 divided by x equals another fraction. Right, this is where we have to think a little bit harder because now we have x in the denominator here, and so we have to get it out. The only way to get it out is to multiply both sides by x. So let's work this one. These cancel out. And then I have 6 equals 5x over 4. Still got a few more steps I need to unwind here. I have x is being divided by 4 and multiplied by 5. So let's undo that divided by 4 by multiplying both sides by 4. So they cancel out. And then I have 4 times 6 is 24 equals 5x. Now I'm just got one step left. Divide both sides by 5. And I end with x equals 24 over 5. Or if you want to simplify this or turn this into a mixed fraction, this 20 is 4 5s, because 4 times 5 is 20. And then there's 4 left over. So I could also write that as 4 and 4/5. Now, if we step back and look for a second, I had to do 2 things to get everything the way I wanted it, to get rid of the denominators. I had to multiply by x, and then I had to multiply by 4. So we have a method for doing that quickly that can get rid of both denominators at the same time, and that's the main thing that we're working on tonight. It's cross multiplying. Right. So if I have 3 over x equals 2 over 5, I'm going to have to multiply by x to get it out of this denominator, and I'm going to have to multiply by 5 to get 5 out of that denominator. So I could multiply both sides by 5 and x, this by 5 and x. Here the x's cancel, here the 5's cancel, and I'm left with 3 times 5 equals 2 times x. This is where we find our trick, is because 3 times 5 is just these two terms, 3 times 5, and 2x is just 2 times x. So when we have a problem like this, we can do cross multiplication, cross multiplying, which is where we take whatever's in the top left and we can multiply it by whatever's in the bottom right, and that'll give us one side of the equation. And we could take whatever's in the top right, multiply it by the bottom left, and that will give us the other side of the equation. So let's finish this equation, solve for x here. We've got 3 times 5 is 15 equals 2x. And then I have to isolate x by dividing both sides by 2. And I'll have x equals 15 over 2. And that's 7.5, or 15 over 2 is a fine way to express that as well. Let's do a couple more problems like that. And see, I can have one where you send me your answer. So 7 over r equals 8 over 2. All right, so do a cross multiplying where you multiply across the diagonal. And then on the other side, you're going to multiply these other two terms. And that will get rid of all of our denominators, and we won't have any more fractions. We'll just have a multiplication problem where it'll be r or x or whatever times something. So I'm going to give you a minute and see if you can work that out by multiplying, doing cross multiplication. Let me see, George, that is correct. So let's work this one out. See if you've got your steps right. So for cross multiplication, then take the top left, multiply it by the bottom right. I've got 7 and 2. So I'm gonna write 2 times 7. And then for the right side of my equation, I'm going to do this diagonal, 8r, or r times 8, but we usually put the number, then the variable. So this 14, 2 times 7 is 14, and then I've got 8r. I'm going to have to move up over here. 8r equals 14. Change it around. Now I'm going to divide both sides by 8, and then I have r equals 14 over 8. And this is the first fraction we've had tonight that can actually be simplified. 14 and 8 are both even, so I have a factor of 2 that I can cancel out between both of them. They have a common factor. So if I divide both of those by 2, I have 7 over 4, which is the same as 1 and 3/4, or as George said, 1.75. Right? All of these are the same number. Acceptable answers mean the exact same thing. Let's do one more like that before we step it up a little bit more. It's got 5 over x equals 2 over 3. So take a minute, see if you can follow the process of cross multiplication to solve for x. And then when you send your answer, just above where you type your message, it says 2. Click on that little blue button and make sure you click on Andy Castro. That'll go to me. Jose, that is correct. And Alexandria, that's correct. Start working this one out. I'm going to cross 5 times 3 is 15. And then on the other side, I have 2x. Then I just have to divide both sides by 2. These cancel out. So x is going to equal 15 halves, or as everybody, it's easier to type, I suppose, is putting 7.5. Same number, 15 halves, and 7.5. All right. Let's take it up one more step. There's only 2 more steps to go. So now we're going to have a problem where we've got 3 over, I'm going to use a this time, a, but it's not just a. We're going to do a plus 1. And that's going to equal 2 over 5. I can do the exact same thing. I just have to be careful about when I do my multiplication that I make sure to distribute to everything, right? I've got 2 terms here, and if it's not written, sometimes it's helpful. Put parentheses around there. It's going to help us here in a second. Because when I multiply the top right and the bottom left, I'm going to have 2 times a plus 1. It's not 2 times a, and then add 1. It's 2 times a plus 1. And then on the other side, I've got 3 times 5 is 15. All right, and now, again, there's always a couple different ways to go about it. I'm going to distribute this 2 into each of these and see how that works. So I'd have 2 times a is 2a plus 2 times 1 is 2. And that still equals 15. Then I need to subtract 2. Right? And this, we're getting back into just solving a problem that we already know how to solve. The 2's are going to go away, so I have 2a equals 13. Divide both sides by 2. A is 13 halves, or 6.5. It's another way of writing that. Okay, yeah. So if we subtracted 1, so I think George sent this. If we had subtracted 1, then 15 minus 1 would have been 14, divided by 2 would have been 7. But that 2 multiplies to that 1. So it becomes a 2, and then when we subtract that, we have 13. Here's the other thing I could do. Instead of distributing, I guess I'll just start this one over and do it the other way. So I could have 2 times a plus 1 equals 15, right? Exact same problem. But I don't have to distribute that 2 right now. I could just divide both sides by 2. And so those would cancel out. And then I have 15 and a half over there. So I've got a plus 1 equals 7.5. And then I would subtract 1 from both sides and get a equals 6.5. So we have to make sure, that's what I was saying at the beginning, this has to be distributed. We have to distribute the 2 to both of those terms. Let's do another similar problem like that. Trying not to pick all the same numbers all the time. 6 over b minus 2 equals, checking to see if we have negatives that you need to deal with right now. We'll just go 3 over 4. Right, so I'm going to cross multiply this way. Got 3 times b minus 2 equals, then I have these 2 diagonals, and 6 times 4 is 24. Right. So again, there are 2 ways I could divide both sides by 3 right now, or I could distribute the 3 and then solve from there. Let's take the short road, and I'm going to divide both sides by 3. So these cancel, and I have b minus 2 equals 24 divided by 3 is 8. I think we had some messages that were really close, but I have to add 2 to both sides now. So b is going to be 10 for this problem. I get down here, I have to add 2. All right, let's do our last step. The most complex problems that we're going to have are going to look, or where we're going to have 2 variables. Right? The variables are going to be in 2 different parts of the equation. So let's start with b plus 1 over b minus 1 is, we'll go 7 over 2. This one's going to take a little bit more work than some of the others. I'm not going to be able to just divide. I have to distribute once I get here. All right, so I've got 7 times b minus 1 from the top right, the bottom left, and then 2 times b plus 1. Okay, so now I've changed it from a proportion to just an algebra problem. I've just got some variables that I need to solve for. So I'm going to distribute my 7. 7 times b is 7b. 7 times negative 1 is negative 7. 2 times b is 2b. And then 2 times positive 1 is positive 2. All right, so now I'm moving variables around, and I'm going to make sure that I am combining like terms. I want my b's on one side, so I'm going to subtract 2b from both sides. So that will leave me with 5b minus 7 equals 2. Almost there. Almost there. Need to add 7 to both sides. So I have 5b equals 9. And then I divide both sides by 5. b equals 9 over 5, or 1 4/5, or 1.8, if you want to make it a decimal. All right, so I can have the variable in 2 different spots. And those 2 spots for now are either going to look something like what we just did. So we could have b plus 1 over b minus 1 equals 7 over 2. Or we could have something that looks like 3 over x plus 1 equals 2 over x plus 2. Right, so we could have an equation where I've got a variable in this denominator and a variable in that denominator, but we're just going to do the exact same thing. So let's work out that equation as an example. If 3 over x plus 1 equals 2 over x plus 2. All right, cross multiplying, cross the diagonal. I'm going to move over here so I have a bit more room to work. 2 times x plus 1 equals 3 times x plus 2. I have to distribute my 2. So 2 times x is 2x. 2 times 1 is 2. Distribute my 3. 3 times x is 3x. 3 times 2 is 6. I want all my x's on one side, my numbers on the other. So I'm going to move 2x off to the other side. I have 2 equals x plus 6. Oh, almost done. I just have to subtract 6 from both sides, and I get x equals 2 minus 6, so negative 4. Right. So these are you can see 2 variables in 2 denominators, or you could see one fraction that has a variable in the numerator and a denominator. But the process is always cross multiplication. Right? I'll do a couple more examples and then I'll have you guys work one and then we will be done. Let's go a little bit more complex. 10 over 7 equals m plus 3 over m minus 1. So I want you to take a second and do the cross multiplication and set up for our next step. This diagonal, that diagonal. So I've got 10 times m minus 1 equals 7 times m plus 3. Seems really bad, but once we get it to this, it's not so bad. I'm going to distribute my 10. 10 times n, so m is 10m. 10 times -1, -10. Now I'm going to distribute my 7. 7 times m, 7m, plus 7 times 3 is 21. And now I'm going to move my variable over to one side. 10 minus 7 is 3. And now I have to add 10 to both sides. 3m equals 31. And I'm going to divide both sides by 3. So m equals 31 over 10, which is 10 and a third. If you want to be really fancy, you can write 10.3, but you have to have this line over to show that it goes 10.33333333 and never ends. All right. Let me give you an example, and then I'll have you send me your answer. So go 3 over 5 equals a plus 2 over a minus 1. So 3 over 5 equals a plus 2 over a minus 1. And that will be our last problem for the night. So I'll give you a minute to work on that. If you haven't copied it, copy it now because I'm going to start working it out too, so I know the answer. Let me show you the first step, and we'll see if we've got the same thing. Everyone else can keep working on their problem if they haven't finished it yet. So I've got 3 times a minus 1 equals 5 a times a plus 2. Did you get to that step? Okay. 3 over 5, a plus 2, a minus 1. So if you haven't solved it yet, I'll work out the answer for you. Get 3a minus 3 and 5a plus 10. George, that is very close. I think you'll catch what happened here in a second. I'm going to subtract 3a from both sides. So I have -3 equals 2a plus 10. And then I have to subtract 10 from both sides. Also very close. So I'm going to flip the sides. 2a equals -13. And when I divide both sides by 2, I get a equals -6.5. So a couple had 6.5. That makes sense why you might end up with that being positive. But it's negative. So be careful you're following the negatives, doing your addition and subtraction right, and keeping track of your signs. It's very easy to miss things just by dropping a sign. Right? All right. Well, thank you all so much. It's been really nice teaching you, and I hope you have a wonderful week.